The next step in the process is fluxing. The chemical action of flux is complex, but in essence, it dissolves oxides that form during heating and acts as a barrier to protect the parent and filler metals during the brazing cycle. Flux is a chemical compound, supplied as a powder or a paste. It's always best to use it as a paste. Flux powder should be mixed to double cream consistency with water and a few drops of detergent. It's applied to the joint surfaces with a brush prior to assembly and heating. It's worth remembering that too much flux will hardly ever cause a problem, but too little will result in poor quality joints. The flux also serves as a temperature indicator. This can be demonstrated with this copper plate, which is first fluxed and then heated. At 100 degrees centigrade, the water boils off. At around 300 degrees, the flux begins to turn white and puffy. It's now active and protecting the metal surfaces. At about 600 degrees, the flux becomes clear and runs like water. This indicates that the brazing temperature has been reached. Notice that the section of metal which was not covered by flux has become oxidized and black. By protecting the surface, flux allows the filler metal to wet out onto the parent material and flow smoothly through the joint area. This can be demonstrated by placing a piece of silver flow 55 on a copper plate without any flux. The plate is then heated to the melting point of the filler metal. The filler metal melts, but doesn't flow out over the surface of the copper. If the process is repeated, but after the parts have been fluxed, the wire melts and flows smoothly out onto the surface of the plate. Comparing the two plates shows the importance of the flux. Flux 100 was used in most of these experiments. This is a general-purpose flux. Easy flow powder could have been used after it had been mixed to a paste. For higher temperature operations, tenacity 4A or 5 would be more appropriate. There are many brazing fluxes formulated to meet the requirements of a wide range of applications. Whatever the metals to be brazed or the method used, there is a Johnson-Matthey flux that will do the job. But there are some occasions when flux is not needed at all, such as when brazing in a protective atmosphere or in a vacuum furnace. It's also unnecessary when brazing copper to copper, provided a filler metal containing phosphorus is used. This can be demonstrated with Johnson-Matthey Silphos 5. The phosphorus in this alloy forms a compound that acts as its own flux on copper surfaces. If a piece of Silphos 5 is heated on a copper plate without any flux, as it reaches melting temperature, it flows out smoothly over the copper. But unless copper to copper is being joined or an atmosphere furnace is being used, the fluxing step is absolutely essential.